In this video, I am going to do the Pulley people free response problem, okay? So again, just remember that we had a kid who was standing on the ground, okay, and he was holding onto a string that was going up and over a pulley. And then there was another kid that was sort of like dangling here, and I'm really bad at drawing stick people, but so he's like dangling on that side, okay? And this is kid A, and this is kid B. And this kid weighs 70 kilograms, or has a mass of 70 kilograms, and this kid has a mass of 60 kilograms, okay? So the first thing it asks you is to draw a free body diagram for each of the kids, okay? So kid A, let's start with him, okay? So we're just going to draw the forces that are acting on him, okay? So the one force is gravity, right? He's standing there, he's on the surface of the earth, so there's a gravitational force pulling him down, okay? Now, if you're standing on any surface and your feet are pushing into the ground, you not only have a gravitational force, but you also have a normal force, okay? And in the case of this kid, he's holding onto a rope that's pulling him up, sort of up off the ground, because this other kid is dangling on the other side. So we would say that there is like a force due to tension, okay? Then, if we look at kid B, we draw a free body diagram for kid B, okay? He has two forces on him. So he is hanging there in the air, so there's gravity in this direction. But also there's the string holding him back up this way, so that is the force due to tension in that direction, okay? So those are the forces, or the free body diagrams for those two students. Then it says, calculate the magnitude of the force exerted by the floor on student A. So you need to know that the force exerted on the floor, or by the floor on student A, is actually the normal force. So I'm going to write an equation that says the sum of all forces is equivalent to mass times acceleration. So for his case, force normal plus force due to tension, because they're both pointing up, it minus force gravitational is equal to mass times acceleration. Okay? So he's not accelerating at all, right? He's not flying up off the surface. So his acceleration is 0. So we have a case of equilibrium. So actually, Fn plus Ft is equal to Fg. Okay? So the normal force is what I'm trying to solve for. So I'm going to also move my Ft over on this side. So normal force is equal to Fg minus Ft. Okay? Let me slide it up a little bit. Now, Fg is the weight of this child. So Fg is mg minus Ft. It's force normal. Okay? And in this case, the tension in the string is actually caused by this kid hanging there. So his weight is the tension in the string. So up here, let's calculate his weight. So his weight is mg as well, which would be 60 times 10. So his weight is 600 newtons. Okay? So we'll just plug in. We get force normal is equal to 70 times 10. So the weight of the kid on the floor minus the tension in the string caused by the weight of this kid dangling, and so we get that the normal force is 100 newtons. Okay, so it's less. He's being like pulled up off the floor. Remember, the normal force is what a scale would read about your weight. Okay, now for the next part, it asks me to look at the scenario where now this kid is climbing up and he's accelerating up off the ground, and you want to know the tension that he is creating here. Okay, so we're going to use his free body diagram to figure out the tension. So in this case, force tension minus force gravitational is equal to mass times acceleration. Okay, so I want to solve for force tension. So force tension is equal to mass times acceleration plus Fg. Okay. And the Fg here is his weight, okay? So I get Ft is equal to 60, the mass of the kid that's accelerating, times acceleration, which is 0.25, plus his weight, which I already calculated is 600 newtons. Okay, so 60 times 0.25 is 15. So 15 plus 600 gives me a force of tension created now of 615 newtons. Okay. Now part D says, as student B is accelerating, will he pull student A up off the ground? Okay. So student A weighs 700 newtons. So if we're pulling on him with 615 newtons, that's not enough to get him up off the ground. So he would stay in place. Okay? So then it says, well, how fast would this kid need to be accelerating in order for him to come up off the ground? So really what that means is, if we look at this equation, he would have to create 700 newtons of tension to get this 700 newton kid up off the ground. Okay? Minus his 600 newtons of weight that's in the other direction must be equivalent to his 60 kilograms of mass times the acceleration. Okay? So for this, you get 100 is equal to 60A. So A is actually, say 100 divided by 60, 1.67 meters per second squared. So that's how fast you have to be accelerating to create that much tension in order to pull the kid up off the ground.